Today we are going to talk about tRNA or transfer RNA. tRNA accounts for about 15% of total RNA in cell. It is the smallest among all RNA, that is messenger RNA, ribosomal RNA. It is single-stranded, directed in 5 to 3 direction, but due to much folding it seems to be double-stranded. It is synthesized by RNA polymerase III in nucleus. It is also called soluble or adapter RNA. So why tRNA is called soluble RNA? Because it is soluble in 1 molar NaCl. And why tRNA is called adapter RNA? Because it transfers amino acid to ribosome for synthesis of polypeptides. Now look at this picture here. This is clover leaf model of tRNA. This is the best model to explain the structure of tRNA. The tRNA is folded to form clover leaf model. Although tRNA is single-stranded, but it seems to be double-stranded. It seems to be double-stranded. 4 loops are present here: anticodon loop, D loop, opposite to D loop, T-side loop present here, and variable loop is present here. Variable loop or variable arm. The role of variable loop or arm is not known. It lies between T-side loop and anticodon loop. Now talking about anticodon loop, it has 7 bases. 1, 2, 3, 4, 5, 6, 7. It has 7 bases, out of which 3 bases form anticodon, which recognize and attach to codon of mRNA. These 3 bases are anticodon, which recognize and attach to codon of mRNA. This is D loop. D loop contains 8 to 12 bases. It is the largest loop. It is the binding site for amino acyl tRNA synthase enzyme. Talking about the T-side loop, it has 7 bases. 1, 2, 3, 4, 5, 6, 7. It has 7 bases, out of which Psi means pseudouridine. This loop is the site for attaching to ribosome. This is the stem where, due to hydrogen bond, single strand seems to be double stranded. This is a stem, this is a stem, this stem is called D stem, this stem is called acceptor stem, this stem is called T-side stem, this stem is called anticodon stem. No hydrogen bond takes place in loop. There is no hydrogen bond in loops. No hydrogen bond. No hydrogen bond. But there is hydrogen bond in the stem. That is hydrogen bond in acceptor stem, hydrogen bond in T-side stem, hydrogen bond in anticodon stem, hydrogen bond in D stem. 3 end. 3 end lies opposite to anticodon loop. This is anticodon loop. Opposite to anticodon loop, 3 end is present. It has CCA. It has CCA OH group. It is the site of attachment of amino acid. 5 in bears guanine nitrogenous base. Now let's know about role of different loop. This loop is T-side loop. The function of this loop is, with the help of this loop or arm, tRNA combines with larger subunit of ribosome. So this loop helps in attachment of tRNA to ribosome. Anticodon loop or arm. This loop or arm recognize codon of or codon on mRNA. Anticodon, this anticodon decides the type of amino acid which will attach to 3 end. This anticodon decides the amino acid which will attach to 3 end of tRNA. D loop or DHU arm. This loop or arm is the binding site of amino acyl tRNA synthase enzyme. This enzyme recognizes and activates amino acid so that amino acid is attached to three end of tRNA. As we already explained, there are four loops are present in this model: anticodon loop, variable loop, ribosomal binding loop, DHU loop. This loop is called ribosomal binding loop. 5 regions are unpaired or seems to be single-stranded in this model. That is amino acid binding site, ribosomal binding loop, DHU loop. This loop is also called DHU loop. Extra or variable arm or loop, anticodon loop. Now their abnormal base sets are present in different loops. The abnormal base present in T-size loop are pseudouridine and ribothymidine. The abnormal base present in anticodon loop is inosine. The abnormal base present in D loop are dihydrouridine. So overall abnormal base in tRNA are pseudouridine, inosine, dihydrouridine, ribothymidine. This is mRNA. Codons are present on mRNA. This is tRNA and anticodons are present on tRNA on anticodon loop. When there is complementary interaction between codon and anticodon, a specific amino acid bind to three end of tRNA. Functions of tRNA: it transfer amino acid to ribosomes for polypeptide synthesis. Initiator tRNA has dual function of protein synthesis as well as bringing first amino acids.